how you used the DEWESoft data acquisition systems at SpaceX.
We had one of the DEWESoft data acquisition systems. We used it primarily for modal testing. Might take a while that's MODAL, but it's putting many accelerometers and different sensors on a structure that you want to characterize the mass and stiffness properties of so that you can correlate a model and make better predictions of how it will respond in flight. Then you hit it with a instrumented impact hammer. So yeah, you actually get to travel around to satellites and things, or spacecraft parts or rocket parts, and hit them with a hammer on purpose to see how they respond. Make sure that your modeling approaches for that satellite or rocket part are accurate so that your simulations of flight will be accurate. And so we used the DEWESoft version. It was really easy to use. It had a great user interface, and it was very portable and robust. And so those were our preferences with the DEWESoft system. And so we could run a modal test really quickly with the DEWESoft system because it was portable. And we used it again on the rocket team at Vanderbilt. We had another one at Vanderbilt in one of the laboratories I worked in, Laser Laboratory for System Integrity and Reliability, run by Douglas Adams. So I did one summer of research there, my sophomore year of college, and they did dynamic sensing things too, and we did a modal test there on our rocket that we flew for the NASA competition. And so yeah, I loved the DEWESoft equipment. We used some things from other vendors as well. Yeah, I didn't have any problems with it. I think accelerometers are very expensive in general, so anything that can be done to drive down the cost of accelerometers is quite helpful. But the system itself was easy to use, convenient, and adaptable.
Gabriele Rebecchini from DEWESoft Italia asked the bottlenecks in your measurements and the biggest challenges you faced when you measured things.
It's a great question, and it's great to hear from the DEWESoft guys. It's just really mind-blowing that you have this partnership with them. I think it's super cool. We saw crazy high accelerations and crazy high frequencies that we needed to measure them at. And we would always, there was definitely a range of accelerometers that could meet our sensing needs in different locations. So the challenges, I think, were pretty traditional things: sensor connections, making sure that all the electrical connections were solid, making sure that the accelerometers were bonded well to the test article or onto the launch vehicle. You'd oftentimes just get bad data, and that can really mess with your plans for developing, testing, and certifying the vehicle. Cost is prohibitive. Accelerometers can be very expensive, and we were always trying to minimize the number we needed on our rocket. So anything to drive the cost down on accelerometers is huge. We definitely use microphones and things like that for acoustic testing, but that wasn't at my domain as much. And then I was starting to get really interested and started tinkering with, in some of the research I did, some of these digital strain gauges that were very reusable and just quick and robust. And I could slap a strain gauge onto a part and get digital data into my data acquisition system. And what was cool about that was it was a little bit closer to the things that cause a part to fail. The thing with accelerations, they can sort of lie to you. You can see 300, 400 Gs of acceleration on an accelerometer and think, oh my goodness, this is the harshest environment ever. But it's not the case all the time. These very high frequency accelerations don't carry a lot of punch with them, and they don't actually bring parts to failure a good bit. And so you can get an accelerometer that's reading very high accelerations, but if it's not carrying a lot of mass punch with it and it's not operating at the low frequencies, it's not going to provide a ton of damage to parts. Whereas if you're measuring strain on something and you measure high strains, you're dealing with serious business. And I was starting to try and research and figure out, are the methods and data acquisition we're using with accelerometers giving us sort of false positives in terms of the real strains people are seeing? Because what we'll do is we'll use the accelerometers, we'll come up with a static equivalent G load that a part would see. Hey, you need to design your part to 40 Gs or something like that. And then the analyst will go then apply a 40 G static equivalent structural acceleration to their design and check out the stresses and strains in the part that would actually break the structure of the part. Transferring from that dynamic space to a static equivalent space, it's really solid on paper, but in practice, you may end up really messing up how much strain you're putting into the part through that process. We definitely were far from having it all figured out, but I really liked those reusable digital strain gauges we were using. They were high accuracy, a lot of sensitivity, and I felt like they really added a diverse perspective in my sensing my sensing challenges. That's what I would say about that. I wish I could give more information, but I loved collecting all that data, and the times I got to use data acquisition software and get to analyze it and see how systems are real systems are responding to dynamic inputs.
Something else that Gabriele wanted me to tell you is to invite you to the measurement conference in Slovenia in April.
Slovenia in April?
Yes.
Wow, that sounds amazing. I'll have to look into it. Not quite as easy for me to get there as you. Are you going?
Yes, I will be going.
Very exciting. Yeah, the opportunities are quite immense. So I'm glad you've got those good partnerships with them.
You were one of the people who encouraged me to go to DEWESoft.
Yeah, I think and that actually brings up something else I was thinking about coming into this interview. As I was just thinking about like advice for young learners and things like that, getting into partnerships and opportunities with real world corporations, companies, institutions, people that are operating in real time, trying to, keep the world running or innovate or bring us into the future. And they have to deal with cost, schedule, budgeting, and whatever we would call the real world problem solving. I think that's just radically important for kids to quickly see what that's like, because so many of the problems that we solve in school per se are, they're invented, they're made up, and that's fine. I think it still exercises the right thinking muscles and physical muscles and conscientiousness muscles, but that nothing can beat actually getting a close loop between the students and the people solving real world problems. And I think you're doing that with DEWESoft, and it's awesome. And it's hard to get set up, but I think it's great.
Yes, it is.